I'm Arisan journalist from BMD, Sector 1, Year 2, Semester 2. And today I'm going to be talking about my IoT project, also named as the Man's-Based Body Feeder. In this presentation, there will be introduction, hardware, assembly, software explanation, and operation test. Starting off, as I have written before in the project proposal, this project presents an automated pet feeding system that be controlled by using a mobile application via Blynk. The system itself is designed to improve convenience for pet owner, especially by dog, because I own one and I decided to help feed my dog by ensuring timely and controlled feeding. About the hardware, this is the actual circuit, and this is the one I have submitted in the project proposal. So the hardware is that the pet feeder is centered around the ESP32 microcontroller, which serves as the main control unit for processing input and executing output. The system itself integrates multiple components, including ultrasonic sensor, the micro solver, 180 degree, and an LED indicator, the green one, all connect to a breadboard for prototype purpose. And I'll be providing the video after this, right here. Assembly. For assembly is that how the base body feeder is made of. Firstly, of course, the entire setup from the circuit before, and in addition, for the what I'm going to call the bone of the assembly is the future board, which I used to make the entire structure and prototype using tape to hold them together. The software. The following code will be the determinant of how the entire assembly functions, which I'm also going to be showing you. Starting off, we have Blynk here, which will connect my device to the Blynk application or webboard. By defining the print serial, we are able to define the Blynk function in the Arduino. This is my Wi-Fi hotspot, actually hotspot name and hotspot password. For the pin, I use pin 27 for the servo, pin 18 for the trigger of ultrasonic, and pin 19 for echo of the ultrasonic, while the LED is 21. These are some of the setup I had before starting, and if the value is false, it doesn't rotate at all, which allow us to perform on a switch or button. For the voice setup, this is why I have set up my stuff for the ultrasonic. Starting off, we have the serial beacon, which will indicate our frequency. The second is the pin mode, which is basically which pin I'm connecting to the ESP32. The trigger pin, echo pin, and the LED. These are the servo attached to it, which will be connected to the Blynk function. And this is why I have wired my ultrasonic to LED, since if the distance is equal to or less than 10, the LED will light up, while if it's more than 10, it won't light up. So this is going to be the indicator of if we have enough food or not, if I put the ultrasonic again into the assembly. The operation test. The following is to show if the assembly works or not as intended to what the proposal have shown. And here is the finished assembly I've made. I know it's looking quite weird, but this is what I can provide, alright? So starting off, we have this right here. This will be where the feeder is, and of course my trusty light, yeah. And you can see there's ultrasonic in there. This is so that they can detect like if we have like that much treat or not, or food in the tray. And I'm gonna show you some magic here. Right, if you put like this in, the green light will light up. Yeah, so this is to mimic, as I said before, this is to gauge if there's enough food or not per time. This is not like the accurate amount. I haven't calculated the amount, like the nutrient the dogs need and the size of their food, for example like pedigree and stuff, but this will do for now for prototype, I would say. And this contraption is the one I've made with model, supposedly to be the hatch. As you can see, the future bone haven't gone through and covered the entire thing yet, but here I'm gonna show something. Put that in. Alright, and this will be my Blynk control board. I put the distance there to gauge if my ultrasonic was working or not earlier, because it doesn't seem to work at one point. And I put two stuff in, the switch and the button. First of all, both of them work the same way. After the switch got turned on, the motor would rotate, and so does the switch. And let's see that. And what about the switch? Kinda, you hear the sound, I'm pretty sure. Alright, second try, I guess. Here, now you can see clearly that the model also for along the way is quite low budget, so this thing came off quite easily, and the light is working as intended. And that will be the end of this video. Thanks for watching, and please leave a like if you like this video, of course. And I'm Arisan, your host for today, and signing out.